Welcome to AI Machine Learning Workshop, the tutorial before your tutorial, presented by Blackmagic AI. So if you want to learn more about us, you can check us out on our website, blackmagicai.com. You can sign up on our email list, like us on Facebook, or subscribe to our YouTube channel. And this is part one in this workshop series. Now, the purpose of this workshop is to learn machine learning with TensorFlow. Now, this can be a confusing topic for beginners, mainly because of poor beginner level documentation. There's competing multiple frameworks, APIs, and tools, and there are multiple ways of doing the same thing, which make the topic very confusing to learn for the beginner. All right, so this workshop will be an overview workshop that will sacrifice and skip many details in preference for a better understanding of the whole picture of the subject. But at the same time, you'll still be able to implement solutions to more popular TensorFlow problems. Now, the reason we call this the tutorial before your tutorial is that this tutorial will provide you the background you need to get more as you pursue other learning resources and more in-depth tutorials. All right, so let's see, what's this workshop all about? All right, a few prerequisites. So you can attend this workshop if you know a little about computer programming. You don't have to be an expert, but just a little exposure. You like writing computer code. You have little or no experience with artificial intelligence and machine learning, and you are curious about artificial intelligence and machine learning, and you want to learn more. Now, do not attend this workshop if you are a seasoned professional AI and data scientist, or if you don't like writing code. So you can still watch this tutorial if you don't like writing code, but we will be doing example projects in this workshop, and you'll get more out of it and a better depth of understanding by writing the code. But you can still watch it if you don't like writing code. All right, some prerequisite knowledge. Programming experience in any object-oriented language, preferably Python. But like I said, just exposure to any kind of programming will help. And you got to know how to use your web browser on your laptop or desktop or whatever you're using. And then you also need a Google Gmail account, because you may be charged a small fee because we'll be using some of the Google Cloud ML Engine services for our projects. And that's it. That's all you need. Okay, so let's start with the topics covered in this tutorial. So this tutorial is divided into two sections, Part A and Part B. Part A, we present the topics and discuss the theoretical background and explanations and definitions of the different topics presented here. For example, we have the first part is an introduction to AI. Then we're going to talk about machine learning introduction. Then we're going to talk about the machine learning pipeline, introduction to TensorFlow and Keras, introduction to Google Collaboratory. We're going to do an introduction to neural networks, and we're going to look at an exclusive or machine learning example project. And then in part B is the more practical part of the workshop, where we actually apply and do the coding and go through an example project together. So in the part B, we'll complete our exclusive or machine learning example project. We'll give you an introduction to Google Cloud ML Engine, and then we'll also show you how to deploy your exclusive or model project to the Google Cloud ML Engine. So that's how the workshop is divided up, and those are the topics we will be covering. All right, starting with the beginning, an AI introduction. So think of AI as a branch of computer science concerned with making computers, machines with the cognitive abilities of humans. So some of those things might be, you have perception, reasoning, we have learning, communicating, and acting in complex environments as well as or better than humans, and that's from a reference. Now, we also have this additional chart kind of illustrating the same thing. So, like I said, the goals of artificial intelligence, cognitive abilities of humans. So we have reasoning, automated learning and scheduling, we have machine learning, we have natural language processing, computer vision, you may have seen some examples of that, robotics, and the holy grail of of AI is general intelligence. So like I said, AI is a broad term encompassing many related topics in computer science. All right, so now that we know that AI, kind of a basic working definition of artificial intelligence, so in order to achieve the goals of AI, remember those cognitive abilities that humans have and put those in machines, there's, in addition to the goals, there are different approaches or ways of achieving those goals. So this kind of org tree chart here shows an example of the relationship of all the different topics. So for this workshop, we're going to start off here with artificial intelligence. We're going to go down this middle branch here. We're going to go off to the left here, down to the machine learning branch. And then in the machine learning branch, we're going to go over to the supervised learning branch. And then we're going to come all the way down here and end at this support vector nodes. So this will be the topic we'll focus on mainly in this workshop. Now, like I said, some of these topics overlap, so you'll also be talking about, we'll cover some neural networks too. But the basic thing to remember is artificial intelligence, there's many, there's goals, and there's many topics in artificial intelligence, and there's also many approaches to achieving those goals that we presented in the previous slide. All right, so we will be talking about machine learning as we showed in the previous slide. Start off here with the machine learning branch, and then we branch off into reinforcement learning. So once we branch off, this shows you some of the applications that we can apply machine learning to and its different approaches. So if we take the reinforcement learning approach, we can do game AI, we can do robot navigation, learning tasks, and things like that. Now, if we go up to the unsupervised learning approach to machine learning, we can do things like clustering, which is customer segmentation, targeted marketing, and then there's dimensionality reduction. And then if we come back to our central hub here, machine learning, and branch off into supervised learning, which is what we will cover in this workshop. So this is the approach that we focused on here in this workshop. Now there are two main applications for the supervised learning part of machine learning, and that's regression. That involves things like estimating things. So we can do like weather forecasting, estimating life expectancy, and also we can do classification. So one of the most popular applications of supervised learning, it's able to do image recognition by telling us what is in the image, like object detection, where we can have an image and find all the objects within the image. So that's a little summary of what approach we'll be studying in this workshop and some of the applications that we'll encounter. Now we need some motivations. Why use machine learning as opposed to an algorithmic approach? So for this, we will do the example of a reactive robot. So think of the reactive robot as an autonomous vehicle in this example, and we have a car, and it has sensors on the left and sensors on the right that can detect obstacles in front. The more traditional approach you might use is the rhythmic process, where we will actually like kind of analyze the requirements of the system. We will do some type of analytical analysis, and then once we get that analysis done, we'll try to like implement that in code. So we'll come up with some algorithms to do that, and then once we do that, we'll show you like why you might want to use machine learning. All right, so if you look at this chart here, this is our first step in our analysis here. We're going to like gather like some of the requirements or the things, how we might analyze this system. So like what are the inputs to our system and what are the outputs? So if you see the two columns, we have left and right. These are two columns represent the input. So these are our sensor inputs. So like on the left, if you see a 0, that means there's no object in front. And if we put a 1 in front, that means that that sensor has an object in front of it. And the same thing for the right. And then the rows represent the outputs for each situation. So we've done an analysis. We've found these are the different inputs, and these are the outputs for the corresponding inputs. So our goal in solving this problem is to figure out the relationships between the inputs and outputs. We will write code or codify that with some algorithm in the language of our choice, and then we'll run that in the computer, and the computer will autonomously drive this vehicle in a reactive robot fashion. All right, so let's start off with our analysis. So if there are no objects in front of any of the sensors, left or right, as indicated here by 0 in the left column and 0 in the right column, the robot will go forward. So that's the forward arrow here. So that's the first input and output relationship that we will define, or we found in our analysis. The next scenario we might want to look at is if there's an object on the left side. In that case, the left sensor will detect an object. There's nothing on the right side, so in that case we want to make a right turn. So these are our inputs. Something detected on the left, nothing in the right sensor, and our output should be a right turn. We can do the same analysis if we have an object on the right side. In this case, there's nothing in front of the left sensor, so that's indicated by the 0. And then on the right, we have an object indicated by 1, and the output for that scenario should be a left turn. Okay, what if we have an obstacle in front of the left and the right? In that case, we might want to stop or do something like reverse. So in this case, we're just going to stop. So like I said, now we've found like our inputs and outputs. Now we have to figure out how do we write code. So now we want to find like what type of algorithm can we write that will reproduce the relationships between the inputs and the outputs. All right, so here's a pseudocode algorithm that we can possibly use as a solution. And in this case, we'll implement it as a basic if-else-if statement. This algorithm goes as follows. If an obstacle is on the left, then turn right. Else, if an obstacle is on the right, then turn left. Else, if there's an obstacle in front of the left and the right, then we want to stop. Else, we move forward. This pseudocode algorithm that we've developed accurately defines the relationships between our inputs and our outputs. So this is fine. So why would we want to use anything else? Well, let's consider something else that might happen. Let's say now we want to add some sensors on the rear of the vehicle. So now we can detect an obstacle on the rear left. In that case, we might want to do a reverse right turn. And we can do the same thing. We might have an obstacle on the rear left. In that case, we want to do a reverse left turn. And once again, we can also have an obstacle on both the left and right rear sides. In that case, we want to stop the vehicle. Now, what we could do if we were doing the traditional algorithmic approach, now we'll have to redo our analysis, find the additional inputs and the outputs we require, and then we'll have to figure out, we might have to rewrite our code, or we may have to like rewrite the code we've previously written so that it will take into account the new logic and the new relationships between the input and output. But if we're using the machine learning approach, what we would do is we would just write some generic code that learns the relationships between inputs and outputs. So we just write this code once that has a learning algorithm in it, treat it as a black box, and what we will do is present it with each scenario for the left and the right as inputs, and we'll also present it with the output that we're expecting. And then the machine learning, our little black box, it will learn the relationships itself without us having to explicitly write code for that. So we'll explicitly write code for the learning algorithm, but as far as like the machine learning algorithm is concerned, all we have to do is present the inputs, the outputs we're expecting, and it will learn the relationships for us. And even if we add additional requirements, all we do is add that additional inputs and outputs that we're expecting, and to train our model or our machine learning model. So in that case, we don't have to rewrite any code or anything. We just present the new data. So as new data comes available, we can just retrain our model, and it can solve the solution. Yes, because you might want to use the machine learning approach in cases where the relationships between the input and outputs are very complicated or very difficult to analyze analytically. So in that case, machine learning model approach is the best one to use in that situation, or one of the better ones to use in that situation. All right, so that concludes this part 1 of the AI machine learning workshop, the tutorial before your tutorials. So once again, you can go to blackmagicai.com, sign up on our email list, like us on Facebook, and subscribe to our YouTube channel.